A milkman has two empty bottles, a 3-gallon bottle and a 5-gallon bottle. How can he measure exactly 1 gallon without wasting any milk? Okay, so we're going to solve this problem using answer set programming. And okay, so the first thing we're going to do is define the literals, the information we already know. In this case, it's going to be just the bottles. So we're going to define a bottle as having an ID number, a certain amount of milk at a given point in time, the time, and the maximum amount of milk the bottle can have. So first we're going to define the first bottle. Bottle 1 is going to start empty at time 0 and a maximum amount of milk. Then the second bottle, which is going to be bottle 2, and it's also going to start empty at time 0 and a maximum amount of 5. And now for answer set programming, we need to define the set of rules that make up the program. So first we need to define the actions that we can make at any given point in time. So what we can do is fill the bottle at a given time t, or pour milk from one bottle to another. And this happens at any given point in time t where we have not reached success. And in here we're going to define success as having 1 gallon of milk at any bottle at a certain point in time. Okay, so first we need to define what happens when we decide to perform the action fill. Is that we're going to fill a bottle, a certain bottle with an ID number, and we're going to fill it at a given time. So we say fill bottle of X at the time t. This happens when we perform fill t, and we're going to do this to a bottle X that has any given amount of milk at a time t and any maximum amount of milk it can have. And okay, let's also define t, which is an integer. And okay, for this rule, you may be thinking, is this everything for this rule? Well, no, because if we leave it like this, we're going to say that we're going to fill every single bottle we have, in this case 2, and we only want to fill 1 bottle at a time. So we need to say that for every given bottle we can either fill it or not fill it. Fill bottle X at time t. Okay, and this little line, what it means is like an atom, but it's negated, and this is a strong negation, where here this one is a weak negation or negation by failure. And that means that whenever we cannot prove this to be true, then this weak negation is going to come as positive. Where in this part, this strong negation, we have to explicitly say that this filled bottle atom is negative. Okay, so now what happens to the bottles when we decide to fill them? Bottle X is going to be full at a maximum capacity at the time t2, and we define also the maximum capacity. So this happens when we say fill bottle X at the time t. We define the bottle X to have any given amount of milk at time t and has a maximum capacity. We define t as an integer, and we say that t2 is equal to t plus 1. And what this means is, for example, if we decide to fill bottle X at time 0, then it's going to be full at time 0 plus 1, which is 1. And we also need to define what happens to the bottle that don't get filled. So in here we're going to say bottle Y, which has a certain amount of milk at time t2 and a maximum capacity. And this happens when we fill bottle X at time t, and notice that we're saying we're filling bottle X, but we're defining bottle Y. And we need to define bottle Y as having a certain amount of milk at time t and a maximum capacity. And notice that the amount of milk we have at time t is also going to be the same we have at time t2 because we're not doing anything to this bottle. So time in t is an integer and t2 is equal to t plus 1. Okay, and for this fill bottle, since for every case we're deciding to either fill or not fill every single bottle, we could also have the case where the program decides to fill both bottles at the same time. We want to only perform an action on one bottle at every point in time. So we're going to write a constraint. A constraint is basically a rule without a head, without a left-hand side. And we're going to say fill bottle X at time t and fill bottle Y at time t, where t is an integer and X is different from Y. And here what we're saying is that we cannot fill bottle X and bottle Y at the same time t. Okay, so now we're going to go with pour bottle, which we're going to say we're going to pour milk from one bottle to another bottle at a certain time. And we're going to say that we can either pour bottle X from bottle X to bottle Y at time t, or not pour milk from bottle X to bottle Y at time t. And this happens when we decide to pour at time t. We need to define the bottles X to have any amount of milk at time t and any given capacity, and bottle Y any amount of milk at time t and any maximum capacity, and we say X is different from Y, and we define t as an integer. And let's see what happens when we pour milk from one bottle to another. Well, in this case we can have that the first bottle will get completely emptied, or that the second bottle gets filled without emptying the first bottle. So we need to define both cases. And in here we're going to define first bottle X. And well, in the first case we're going to say that the bottle gets emptied, so it's going to have 0 milk at the time t2 and a maximum capacity. And this happens when we decide to pour bottle from X to Y at time t. We define the bottles X to have a certain amount of milk X at time t and a maximum X, and we're also going to define that here, max X. We define bottle Y to have a certain amount Y at time t and a maximum capacity of Y. And let's see, we're going to say that the sum is equal to the amount of milk in both bottles, so current X plus current Y. And we're going to say that the bottle gets emptied when the maximum capacity of the second bottle is higher or equal than the sum of milk in both bottles. Okay, so let's also say x is different from y, and we define t as an integer, and t2 is equal to t plus 1. And let's say what happens to the other bottle y. It's going to have a certain amount of milk at the time t2 and a maximum of capacity of y. And this happens when we pour milk from bottle x to bottle y at the time t. We define both bottles x with an amount current x at the time t and a maximum x, and we define bottle y at the time t and a maximum of y. And we're also going to say that the sum is equal to current x plus current y, and this happens when the maximum of y is higher or equal than the sum. And in here, actually, the amount of milk in bottle y is going to be equal to the sum, and we say x is different from y, and we define t as an integer, and we say t2 is equal to t plus 1. Okay, so that is the first case. Now we're going to define the case where the second bottle gets filled before the other one gets emptied. So let's say bottle x, it's going to have a certain amount at the time t2 and a maximum capacity of max x. This happens when we pour milk from x to y at the time t. We define both bottles x current x at the time t and a maximum of x. We define the second bottle y, and the current amount y at the time t and a maximum y. And we're also going to say sum is equal to current x plus current y. And in this case, it's going to happen if max y is lower than the sum. And in this case, the amount of milk in the first bottle is going to be equal to the sum minus the maximum of y. And we define t as an integer, and t2 is equal to t plus 1. Now we need to define what happens to the other bottle y. It has, and actually in here we're going to say that it gets filled, so the amount of milk is going to be equal to max y at time t2 and a maximum capacity of max y. And this happens when we pour from bottle x to bottle y at the time t. We define both bottles current x at the time t and maximum of x, and we define the second bottle y has a certain amount of milk at the time t and a maximum of y. We define the sum to be equal to current x plus current y, and we say that the maximum of y is lower than the sum, and we define t as an integer, and t2 is equal to t plus 1. And okay, oh, and for this action per bottle we also need to define that we cannot pour milk from more than one bottle at a time. So we're going to say X, we pour from X to, I don't know, any bottle at the time T. And we also decide to pour from bottle Y to any bottle at time T, where X is different than Y and T is an integer. Okay, and now we need to define the atom of success. We're going to say that we achieve success when at any point in time T we have a bottle with an amount of 1 gallon at any point in time. And we're going to keep success at time T2 if we achieve success at an earlier point in time T. So we define T as an integer and T2 is equal to T plus 1. And okay, in this case, if we run the program like this, it's going to give us every possible solution, and we want to find the optimal solution. In this case, the optimal solution is the one with the least amount of steps. So we're going to write a weak constraint, which is constraint with this little curly line. And basically what the difference between hard constraint and weak constraint is that the hard constraints are things that we absolutely do not want to happen, and the weak constraints are things that can happen, but we prefer not to have them happen. So we're going to say that we do not want not success at time T, where T is an integer. And so with this, the program is going to try to reduce the number of steps where we do not have success. And with that, it's going to give us the plan with the fewer amount of steps possible. Okay, so we're going to save this and we're going to run the command line dlb.bin. And in this case, this file is the one that is the solver that runs answer set programming. We're going to write silent just so we don't get information about DLB. And we have to define capital N, which is the integers we can have in this program, let's say 10. And with this, we can say that that this plan, let's say, can have at most 10 steps. And well, basically this defines every single integer. For example, the current amount of milk, the maximum amount of milk. We cannot have at any point any value that is higher than 10. And we give it the name of the file, which is milk problem. Okay, and if we run it like this, it's going to give us every single literal for every point in time. It's going to give us the fill action, the state of the bottles at every point in time, and we only want about the actions, so we're going to write p filter, and in here we want the literals, only the literals that we want to see. So we're going to say fill bottle and pour bottle. And okay, let's try to run this. And we have, okay, let's just say lowercase n is equal to 1, so we can only have one plan. And okay, we did, okay, let's see. Fill bottle. Okay, yeah. Okay, it's not in order, but yeah, whatever. Okay, let's try to put this in order, and I'm going to do that over here. Okay, let's see. Now we did something wrong. Okay, yeah, this cannot be right. What? Okay, maybe we made a mistake somewhere. Okay, I think maybe in this one we didn't say that x has to be different from y. And okay, yeah, that was it. If we don't, yes, we have to specify that, sometimes we have to specify that certain variables cannot be the same, because otherwise the program can assume that they can. Okay, so let's, okay, I'm going to write the steps over here. The first one, we have fill bottle 1 at time 0. So with this, we're going to have bottle 1 has 3 gallons and bottle 2 has 0 gallons. Then we pour from bottle 1 to bottle 2. Pour from bottle 1 to bottle 2 at time 1. And with this, bottle 1 is going to be emptied. And bottle 2 is going to have 3 gallons. Then we fill bottle 1 again. Fill bottle 1 at time 2. And let's just comment this. And with this, bottle 1 is going to have 3 gallons and bottle 2 is going to have 3 gallons. And then we pour from bottle 1 to bottle 2. Pour from comment bottle 1 to bottle 2 at time 3. And with this, bottle 1 is going to have 1 gallon and bottle 2 is going to have 5 gallons. And there you go. That was answer set programming to solve a simple problem like the milk problem. So, leave a comment and let me know what you guys think. If you can try to expand this to have an indefinite amount of bottles. This specific program will only work for 2 bottles. But in a future video we can expand it to have several bottles, and we can also add an extra action that we can empty the bottles, and we can try a different problem. And well, that's it. If you want, leave a comment and let me know what you guys want to see in the future.